We have now covered all the material that we're going to this year in Algebra 1. We are on the review. The first thing we're going to do is today's review is just about Unit 8 and quadratics. So we're going to look at solving quadratics and graphing quadratics. So describe the number of solutions a quadratic equation can have. Now this first question is actually one that we did just recently. It's more in the graphing, but it's good to review. It doesn't matter where it's located. So when we look at graphs, our options for graphs is that we have basically 3 types. Now these, I'm going to make them all opening up. They can all open down. It doesn't make any difference. So one option is they come down and they hit twice. They cross the x-axis twice. One option is they come down and they hit it once. And in math we say that that's bouncing off, so it bounces off. So it hits once. And then the other one is where it doesn't touch at all. Okay? Show where the solutions would lie on the graph that you drew above. So this is where our solutions would lie. On this one, remember, this is imaginary roots. So we are not prepared to answer that question yet. These are imaginary roots or solutions. So they don't have x-intercepts. The solutions for these two would be where it crosses the x-axis. What are they also known as? So what this is asking is when we talk about solutions, they are x-intercepts. They are roots. You've heard me use that several times. So solutions, x-intercepts, roots.
Any available?
Sorry for the interruption. So solutions, x-intercepts, roots. Those are all names. And for now, those are all interchangeable. When you get into imaginary roots or solutions, then it does change a little. And actually, it's imaginary solutions. Anyway. Okay. So next thing, solve each quadratic equation by factoring. Oh, our favorite. So remember factoring. We're going to make our x. We're going to multiply a times c, put it up at the top. B goes down at the bottom. And if I haven't already said it, which I haven't, I'm hoping you already did this by yourself and that you're trying it on your own. Or if you're like, nope, don't remember it, then do 1 or 2 with me and then go and do it on your own. Or pause it whenever so that you can see what you know and don't know, because this is all going to be on the final, so you want to make sure you know how to do it. So try it on your own first is always best, and then just watch to see how it's done. Okay, so we want to list the factors of -24. Then when added, give us -10. So we can just list all the factors of 24. It's a short enough one. That's not a problem. And then, of course, it's a -24, so my signs are different. When I add, I get a negative. When I multiply, it's a negative, so my signs have to be different. When I add, it's a negative. So therefore, I know my larger factor, because when I add, my larger factor determines my sign. So which pair is it going to be? 4 and -6. Wow, there is not enough room to do this on here. So I'm going to get some scratch paper. You might want to do that too if you haven't already. So from here, then, we're going to write it out as our 4 terms. So x squared minus 10x minus 24. Hello. Write it in 4 terms, not rewrite the problem. So x squared plus 4x minus 6x minus 24 is equal to 0. And a lot of times you can just get it all the way down to where it's factored and then stick the 0 back on. But I do want you to know you are solving, so pay attention. So factor by grouping. Take an x out. Here, third term is negative. So you want to take out a negative, and then the greatest common factor is 6. And of course, when I divide through by a negative, it makes them both positive. Okay, we factored it completely. Once we've factored it completely, we take each of them and we set them equal to 0. And we solve. We get x is equal to -4, and x is equal to 6. This is one way to write the solutions. Remember, the other way is to put it into set notation. Oops, do not do what I just did. Don't put a parentheses on. That's an ordered pair. We have to put set notation, so that's a beautiful bracket there, huh? Okay, on B. If you want to try it on your own, we're going to make an x. Multiply 3 times 45. So when we multiply 3 times negative 45, we get a negative 135, and we get a negative 6. With negative 135, obviously we're not going to list all the factors, but start playing. And what I've started doing now, too, is put in what I already know. I know that I have 3, and I have 45, and I know that one has to be negative. Well, that's a 42. So we know we're way off a negative 42. So that just kind of gives you an idea of what's going to be positive, what's going to be negative, and then you go from there. So again, what you're doing, and hopefully you're brave enough to try this on your own, is that you're going to take 135 and just start dividing it by stuff. So I divide it by 5. Well, that gave me 27. 27 minus 5 does not give me 6. Okay? So I know that's not it. So then I took 135. Well, then I was like, wait, if 6 goes into it, that means 3 does. That's the wrong way. Oh, duh, I already have that. Okay, but if 3 goes into it, notice we have a 45. That means 9 does. So I went to 9 as my next one. And I got 15. So 9 and negative 15 gives me the negative 6. So I start playing off what I know. I know the factors of 45 are 5 and 9. So I already tried 5, I already tried 3, so I went with 9. Came up to be that 15. Okay, so you have 9, negative 15. So we're going to write it out as 3x squared plus 9x minus 15x. And again, please, please, please stop the video when you're getting it. Do it on your own and then just come back and check the answer. I have no problem you fast forwarding through me. Okay, so feel free to do that. Factor out the 3x. Third term is negative. Factor out a negative 5. Oh no, factor out a 15. So I knew I was making a mistake here someplace because I was like, wait, I have to come up with an x because I have that, so I can take out a 15. I wasn't paying attention. Now this is the beauty of solving instead of just factoring. And you're going, what are you talking about? Look right here. There was a greatest common factor to begin with. At the very beginning, we could have taken out a 3. Now, because we're solving, it doesn't matter. It does not matter. We can just leave all those greatest common factors in there. If I were factoring, you'd need to take a 3 out right now. But because I'm solving, I can just set them equal to 0 and go. That's the advantage with solving. If solving, I can do that. So I'm going to subtract 3. So our answers are negative 3 and 5. Negative 3 and 5. Okay, good. Now, C, what makes C different? Look at that. You're right, it's because we don't have a 0 on a side by itself. So we have to get that 7 over. Make my x over here, see if I can make it fit. Negative 7 and 6. Oh, the factors of 7. Well, that doesn't give us a lot of choice, does it? It's going to be 1 and 7. And we have to add, so that means 7 has to be positive. So we get x squared minus x plus 7x minus 7. Okay, good. Okay, solve each quadratic equation by taking the square root. In order to use square roots, remember we have to get the perfect square on a side by itself. The perfect square, the squared term, on a side by itself. Okay, so in this situation, I like to keep everything positive, so I'm not going to deal with negatives. So I'm going to move this to the other side. And it's just because I'm lousy with negatives and I forget them. So I get x squared equals 225, or 225 is equal to x squared. I like my variable on the left-hand side, so I'm going to move it there. X squared is equal to 225. And if I have an x squared to undo it, I have to take the square root. And remember, when we put the radical on, we added the radical. It was not in the original problem. We must put a plus or a minus. So we get x is equal to plus or minus 15. Those are my two answers. That is a fine and dandy answer. If we're being picky, then yeah, write them both out. This is a bad habit from being in advanced math classes. You just leave it like that. Okay, here we go again. Pause your video. Try it on your own. You can do this. Try it on your own. Pause your video. I'm going to keep going. I'll let you decide, but I would suggest pausing your video. Oh, did you catch? I want you to pause your video. I think it'd be a good idea. We have to get the squared term by itself. We're going to take the square root of both sides. When we do that, we have to put a plus or a minus. Do you notice what's happening here? We got a negative underneath a radical. If we have a negative underneath a radical, we are not equipped to do that right now. We have not learned about imaginary numbers. So what we're going to say is, not yet. We can't find a solution. Okay? Not yet, or it's an imaginary solution. We could put that in there. Because we have not learned about how to solve imaginary numbers yet. Good. Okay, C. Try it on your own, try it on your own, try it on your own. Pause it. Yes, do it. Okay, so I'm going to move the 27. I have to get the squared term by itself, so I'm going to divide by 3. And you can see why this method is loved by most people, because look how fast it is. But you have to have a square term in order for it to work. Take the square root of both sides. We put a radical on. We have to put a plus or a minus. Square root of 9 is 3. So 3 and negative 3. Oops. Okay. Good. Oh, yay! Solve each quadratic equation by completing the square. Okay. Remember, our first thing is we have to move that 3 to the other side. Then we're going to take half of b. So b is negative 10. So half of b is negative 5. I'm going to square that. What is negative 5 squared? Put these in a different color. So you can see I am forcing this. This is where we're actually going to do the completing the square. We are going to complete the square ourselves. So now, when we do that, we're going to get 22 is equal to, and I can take, and this is a perfect square trinomial, so I can factor it. You with me? Okay, and now what we're going to do is we're going to take the square root of both sides, because I have a square term, just like what we did up here. I have a square term. It just happens to be a funky looking one. I'm going to take the square root of both sides. Oh, we put that on there. We have to put a plus or a minus where the number is, not on the side where the variable is. So what we have is, I'm going to switch these sides. X minus 5 is equal to plus or minus the square root of 22. So I'm going to add 5 to both sides. And therefore I get x is equal to 5 plus or minus the square root of 22. Oh, and we have to go further because it says round to the nearest hundredth. If we weren't rounding, that would be a fine answer. But because we're in Algebra 1, we have to keep going. So then that breaks down into 5. Oops. So I'm going to kind of make it like this. 5 plus square root 22. 5 minus square root 22. Pull out the calculator. 5 plus square root 22, hit the toggle button, and we get to the nearest hundredth. That's 2 decimal places. So that's going to be the 9. Look one behind it. So 4 below, let it go. We let that go. So this is 9.69. And then we take 5 minus the square root of 22. Hit the toggle button, and we get 0. Okay, so look at this, we're rounding to hundredths. So it's the 0, look one behind it. That's a 5 or above, so we give it a shove, so that's 3.31. These are our 2 solutions. Okay, good. Try this one on your own. Make sure you get that 16 over first, so I'm going to move that 16 over. Oh, wait a second. We have to get it be equal to 0? But aren't we then going to just move the constant back? Yeah. Here, see what I'm saying? Here we had to move the constant over. Constant's already there. Don't make more work for yourself. Okay, this one's trying to be tricky. You can't complete the square unless a is 1. Divide through by a -4 to begin with. Okay, because a has to be 1. We can't have a coefficient other than 1, so we get x plus 2x is equal to 4. X squared, thank you. Okay, now we're going to complete the square on this one. Did not give myself enough room, sorry. X squared plus 2x, leave a space. Half of 2 is 1. 1 squared is 1, so I'm adding 1 here. This is a perfect square trinomial, so I factor it. I now have a squared on one side and a number on the other, so I can just take the square root of both sides. I have to put the plus or minus on the side the variable is not on. This one has a variable, so I have to put it over here. So I get x plus 1 is equal to plus or minus the square root of 5. Move the 1 over. Okay, pull out your calculator. Oh, well, we'll separate them first. -1 plus square root 5, -1 minus square root 5, calculator. So on -1 plus square root 5, we're going to get 1.24 after we round. And so what I'm talking about here on the -1 minus square root 5, notice what I come up with, 0.236. So I have a 3, that's my hundredths. I'm going to go 1 behind it. 5 or above, give it a shove. So it's a -3.24. Those are my two answers. Okay, good. We are almost there. Stay with me. So this problem, the area of the figure is 160 square units. Find the value of x by completing the square. Okay, if you say so. So what we're having to do is we have to find the area. So we find the area of this one, and that is a 4 by 4. So that's 16. This one is 4 times x. So that's 4x. Same thing here. I'm going to keep adding. This one is a 4 by x. This one's an x by x, and this one's an x by x. So I have another 4x. I have another x squared, and an x squared. So now combine like terms. I get 2x squared, and plus 12x plus 16. Now, where we have to go back is remember that the area is 160. So this is equal to 160. Okay? Now, the next thing we have to do is we need to realize that if we're going to solve this by completing the square. Okay, so let's be perfectly honest. If I were solving this one, I'd bring that 160 over and solve by quadratic formula. But they said complete at the square. We're going to complete the square. In order to complete the square, a has to be 1. So the first thing I'm going to do is I'm going to divide everything through by a 2. And therefore I have x squared plus 6x plus 8 is equal to, is that 80? Okay? So that's what we're going to be solving by completing the square. Okay, so now we're just going to have to move the 8 over. So I have x squared plus 6x is equal to 72. I'm going to take half of b, which is 3. I'm going to add 9 to, oh, hello, yeah, and add 9. Take the factor of this perfect square trinomial. Combine here. Okay, you with me? Now remember, when I have a squared term on one side, I'm going to take the square root, the plus or minus. So this is, I'm going through the review. If you have questions about what I'm doing here, come in and ask me in class. Have me practice some more. Ask questions, ask questions, ask questions. Okay, so now this gives me, I'm going to move over here so I have room. X plus 3 is equal to plus or minus, square root of 81 is 9. Subtract 3 from both sides, so I get x is equal to -3 plus or minus 9. break it into the two parts, negative 3 plus 9, negative 3 minus 9. Here I get 6, here I get negative 12. Okay, now this is where you have to pay attention once again, and this happens all the time, especially in physics. It looks like these are my two answers, right? 6 and negative 12. Look back at your problem. If I have an area that's positive, can I have a side that's a negative 12? No, because I'm going to come up with, it won't work. I can't have a side of negative 12 units. So that means this one gets crossed off. What is x equal to? Just 6. Just 6. Okay? And again, don't worry about it for the final, but this is a concept that is used a lot in physics and algebra 2, is you have to pay attention. In the real world, can I have a side that's negative 12? No. Okay, this last problem lists the discriminant, the number of solutions, and the solutions if they exist. They all exist. Some are just imaginary. Solve using the quadratic formula, round to the nearest hundredth if necessary. Okay, so remember the discriminant, b squared minus 4ac. Okay, so we're going to plug that information in. Here is a, b is negative 9, c is negative 4. So I get b squared, negative 9 squared, minus 4 times a times c, negative 4. 81 minus 16 times 2, that's a negative 32. I'm going to add, so I get 313. Okay, so what's the discriminant? 113. Oops, I can't see my work. Number of solutions, well, it's positive. So I'm going to have two real solutions. Now I'm going to plug that in for quadratic formula, okay? Quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So here we go. But remember, we already have this. So negative b, negative 9, plus or minus the square root of 113 all over 2 times a. Square root of 13, we're just going to go right to that. And round to the nearest hundredth, 2 decimal places. So we get 10.63. So now we break it into our two answers. 9 plus 10.63 divided by 4. 9 minus 10.63 divided by 4. And we get 4.91. And negative 0.41. Those are our two answers. Okay, good. Feel free to try these next two on your own, just because they're not too hard to do. But you can also keep watching. A is 3, B is negative 5, C is 10. So that's going to be B squared that's 25 minus 120. Ah, and look at that. We know we're going to get a negative. It doesn't even matter what it is. Okay, but they're asking for it. So 120 minus 25. We get a negative 95. That's our discriminant. So number of solutions? 2, imaginary. Solutions? Not yet. We don't know yet. We haven't learned it yet. Okay? C, again, try it on your own. B is 0. C is negative 12. Well, and we also kind of we've already had the other two. Okay, so B squared minus 4 times AC. No, it might not work out what I thought it was going to do, because it's B that's 0. So that's going to give me negative 16 times 12. 192. That's going to give me a positive 192. Number of solutions, 2 real. We didn't come up with any of the 0 ones, so don't listen to me. Okay, so now that's going to be negative b plus or minus the square root of 192 all over 2 times 4. Oh, this would have been a perfect one to solve by square roots. Square root of 192 is going to be plus or minus 13.86 all over 8. So it's going to be plus or minus of this. So plus or minus 1.73. So a positive 1.73 and a negative 1.73. Okay, good. Okay, so that's a review of solving. The next video will be about graphing. Great.